Matt McMullen, and today I will be discussing a presentation on fire dynamics. During this presentation, I will list the 5 classes of fire and describe the fire growth process for each, the similarities, differences in premix and diffusion flames. I'll explain heat of combustion and combustion efficiency, the similarities and differences in the fire triangle and the fire tetrahedron. I'll define the dangers of smoke and how the differences in flames apply to smoke. Class A ordinary combustibles. These are things such as cloth, wood, plastics. Start relatively slow in the incipient stage and then continue into the growth, fully develop, and ending with decay. They're extinguished by water or cooling the area. Class B ignitable liquids are gasoline, propane, things like paint thinners and others like that. They ignite relatively quickly and go from incipient to fully develop quite suddenly. They're extinguished, these fires either let the liquid or gas burn off, or cool the fuel, remove air, and prevent the fuel from reaching the combustion zone. Class C fires are energized electrical equipment. They involve any of the other classes of fire, however they are energized. Follow the same growth stages as other classes. They're extinguished with extinguishing these fires by disconnecting the electrical source, and you must use extreme caution because there is an electrical source involved. Class D combustible metals, things such as titanium, magnesium, and lithium. They start their growth process from things like car fires or scrap yards. Apply dry powder or sand. Also water can extinguish them, however you must be cautious because it can create a violent reaction with the metal. Class K, these are cooking fires, normally start in kitchens, commercial or residential kitchens, and grow from the growth to the fully developed stage quite suddenly due to the oils. Saponification, or turning the oil into soap, or stifling it and eliminating the oxygen, are ways of extinguishing these fires. There are 2 different types of flames, diffusion and premixed. Similarities between the two. Both need oxygen to facilitate the chemical chain reaction, that is fire. Both produce byproducts of incomplete combustion, such as carbon dioxide, carbon monoxide, and other toxic chemicals. Both also give off heat. The differences have to do with the way the oxygen and fuel are processed. In a diffusion flame, O2 and fuel are processed together at the fuel's flammable range. So you have oxygen and fuel coming together to create that combustion. Flame burns orange, like what you would normally see on a structure fire or any other regular fire. The premixed flames, the O2 and fuel are obviously premixed before the combustion process begins. Premixed flames are more complete and efficient than the diffusion flames, and premixed flames also burn blue. So here you have oxygen entering a port with the fuel simultaneously and continuing and creating the flame or combustion process. Heat of combustion is how much energy a fuel can give off during the oxidation process. Also indicates the amount of energy per unit of mass contained in the fuel. To figure out how much energy is being used, they conduct an experiment called a oxygen bomb calorimeter. This uses higher amounts of oxygen and measures the mass loss and the energy released to near complete combustion. However, 100% complete combustion can never be fully achieved due to the loss of heat into the atmosphere itself. It cannot achieve full diffusion of O2 and fuel in the flammable range. Similarities of the fire triangle and the fire tetrahedron are obviously you need oxygen, fuel, and heat to create the combustion process. You remove any one of the three and you have eliminated that process. The difference comes when you have the fire tetrahedron having a chemical chain reaction that is involved, which would be the fourth process. Just like the fusion or premix flames, you need a chemical chain reaction in the fuel and oxygen to continue the chemical chain reaction. Eliminate that and you no longer have combustion. Smoke is an asphyxiant, displaces oxygen, which is extremely dangerous to humans. The byproducts of incomplete combustions are things such as carbon monoxide, carbon dioxide, water vapors, and other toxic chemicals that are dangerous to human life. These are transported by convection and can heat up other areas that are not yet involved, going from one room to another and start continuing the fire on. And so on. So that's called flame spread. So flame spread is higher in premix flame than in diffusion flame. If flame speed is rapid, they disperse the hot gaseous smoke, and if pressurized in a container such as a structure, it can be extremely dangerous and explosive if the correct amount of oxygen is let in. Cooling the hot gas and smoke is a way to limit fire spread and limits the dangers to firefighters and also the occupants involved in the structure. That concludes my presentation.